this video, I'll be taking some of the questions involving Bernoulli's equation. This is a very important topic for GATE. So prepare this topic very thoroughly. Okay. First question: water flows through a venturimeter. Density is given as 1000 kg per meter cube. Flows through a venturimeter with inlet diameter 80 mm and throat diameter 40 mm. Okay, let me draw a rough sketch of venturimeter. Okay, so the inlet and throat gauge pressures are measured. This is keyword, gauge pressures are given. They are measured to be 400 kilopascal and 130 kilopascal respectively, assuming the venturimeter to be horizontal and neglecting friction. That means we have to neglect the frictional losses and minor losses. The inlet velocity in meter per second is okay. So let us apply the Bernoulli's equation at this section and the throat section. Okay, let this be 1 and this be 2. So what is Bernoulli's equation? P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. You know the terms. P stands for pressure, velocity, and this is height. Okay. So, and we have neglected the frictional losses and minor losses. Okay. Now, what does the question say? That the gauge pressures are measured to be 400 kilopascal and 130 kilopascal at inlet and throat. Okay. So P1 becomes 400 kilopascal. P1 400. So you have to put it here in pascal. Okay. Beware of the units. Be very sure about the units. Rho. What is rho? Rho is 1000 kilogram per meter cube. Let it be G. Okay. V1 square by 2g. You have to find the inlet velocity. Inlet velocity is V1. That is this you have to find. So let it be V square by 2g plus Z1 and Z2. What about Z2 and Z1? As this is horizontal, so there is no height difference. So Z1 is equal to Z2. Okay. This gets cancelled out. Okay. Is equal to P2. P2 is 130 kilopascal. So change it in pascals by rho g. Great. Plus V2 square by 2g. V2 is the velocity of water at throat. Okay. So this G gets cancelled out. Okay. Now, can you find V1 and V2? I mean, can you find a relationship between V1 and V2? Yes, you can, with the help of continuity equation. So one thing I can tell, that Bernoulli's equation is generally asked with continuity equation. Okay, so Bernoulli's equation and continuity equation are clubbed in a question and then the question is asked. So continuity equation is A1 V1 is equal to A2 V2. Great. So A1, what is A1? That is pi by 4 d square. The inlet diameter is 80 mm. Be careful to change it in meters. Pi by 4 d square into V1 is equal to pi by 4 d2 square. That is 40 mm. That is 0.04 meter into V2. Okay. So from here you get a relationship that implies 4 V1 is equal to V2. Okay. So 4 times velocity at first section will be equal to the throat velocity. Obviously the velocity here will be more and here at section 1 will be lesser. Okay. So put this relation here. We have to find the inlet velocity. So we will substitute V2 in terms of V1 to directly get V1. Okay. So this gets cancelled out. This gets cancelled out. So 400 minus 130 is equal to, I mean, it is V2 is 4 V1, so that is 16 V1 square by 2 minus V1 square. Solve it. You will get V1 is equal to 6 meter per second. Okay, so once again check that you have to find inlet velocity. Yes, and you have found out inlet velocity. Great. Now check the units. Meter per second, you have to fill the answer. You have got the answer in meter per second. So now fill 6. Okay, these type of questions are simple, but do not commit any careless mistake, any calculation mistake. Okay, next question. Within a boundary layer for a steady incompressible flow, the Bernoulli's equation. Okay, this question is based on your concepts, on your basics. Do try it once before seeing the solution. Given that within a boundary layer for a steady incompressible flow within a boundary layer, the Bernoulli's equation will hold, will not hold, or whatever the options are. Do try it once before seeing the solution. So if you have solved this question, let me tell you that inside the boundary layer the flow is viscous. Okay, you know this, and the flow is viscous due to which the boundary layer develops, and as viscosity is present, so frictional losses are also present, and therefore Bernoulli's equation cannot be applied. So D will be the option. So, and I must repeat that Bernoulli's equation is applicable only for inviscid fluids, steady and incompressible flow. Okay, so do keep this in mind. It was a good question based on your concepts, basic concepts. So D is the answer. Next problem is a tank open at top with a water level of 1 meter as shown in the figure has a height of 0.5 meters. Okay, a tank open at top with water level 1 meter has a hole. This is incomplete. I mean, has a hole. This should be has a hole at a height of 0.5 meters. A free jet leaves horizontally from the I don't know what it is. A free jet leaves horizontally from the, this is a typing error. So we know that there is a hole and free jet is leaving from this tank. Okay, so this is the problem. The distance x where the jet strikes the floor is. Okay, so you have to find this distance x. Okay, now let me mark this point as 1. Okay, just outside this hole as point 2 and this point be 3 where the jet strikes. Okay, so now I have to find velocity at 2, and that is how I can approach the question. If I got the velocity at point 2, I will be able to find this distance x. So what can I do to find the velocity at point 2, the point which is just outside the hole? Okay, so there must be some velocity. So can I apply Bernoulli's equation between 1 and 2? That will be P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. Okay, P1 is equal to P2 is equal to P-ATM. This is clear because 1 point is just above this surface and 2 point is also in the atmosphere just after the hole. Okay, so this and this gets cancelled out. Z1, let me take Z2 this as datum. So Z2 will be 0 and Z1 will be 0.5 meters. Why? Because this is 0.5, this will be 0.5 meters. Okay, so this will be 0.5 meters. Okay, now V1 will also be 0 because the water here is still. Okay, so it will be 0. So V2 square is equal to 2g 0.5. That implies V2 will be equal to root g meter per second. Take care of the units. Okay, and that will be equal to 3.132 meter per second. V2. Okay, now to find this distance x, see the beauty of this question. The question has been clubbed with kinematics, the equation of kinematics, which you have studied in your 11th and 12th classes. So now this V2 is in x direction and there is no component of velocity in y direction. Okay, v2 is in x direction and there is no component of velocity in y direction. So we can apply the equations of kinematics in the x and y directions respectively to get this distance x in x and y direction respectively. Okay, so when I apply it in x direction, that equation s is equal to ut plus half at square, this you have studied. So s becomes the distance x in x direction. Okay, x is equal to ut. What is u? Let it be ux, that is the component of velocity. Ux is the component of velocity in x direction, t is the time. Is there any component of acceleration in the x direction? No, there is no component of acceleration in the x direction, so this term will become equal to 0. Okay, now we don't know x, we don't know t, however we know ux. Ux will be equal to v2. Okay, let me write it here only. So now we have to find t to get x. Now let's apply this same equation, s is equal to ut plus half at square in the y direction. Okay, so what will be s in y direction? It will be this distance, this height, 0.5 meters. So 0.5 meter is equal to, is there any initial velocity component in y direction? No, I have explained earlier. So this terms becomes 0 plus half at square. Is there any component of acceleration in y direction? Yes, gravity is acting. So half gt square. Okay, so from here you can get t by solving this. G, you know the value of g, yeah. So t will be 0.3192 seconds. Okay, put g is equal to 9.81 meter per second square, multiply, divide everything. After doing everything, you get t is equal to 0.3192 seconds. Okay, put this t here. Can you get x? Yes, you will get x. That implies x will be 3.132 into 0.3192 meters. That will be 1 meter. Okay, so the option will be B. So it was a nice question that was clubbed with your basics of +1 and +2, 11th and 12th. That is, you have to use equations of kinematics also. Okay, next question. A frictionless circular piston of area 10 raised to the power -2 meter square, piston of area, this is the data, mass 100 kilogram, skins into a cylindrical container of the same area, filled with water of density 1000 kilogram per meter cube as shown in the figure. Okay, the container has a hole of area 10 raised to the power -3 meter square, again a data. This hole's area, okay, is 10 raised to the power -3 meter square. At the bottom, that is open to the atmosphere. Assuming there is no leakage from the edges of the piston and considering water to be incompressible, the magnitude of the piston velocity at the instant shown is. Okay, so this piston is moving down. Let this be 1 and this cross section be 2. I mean, this is in atmosphere. Okay, so this be 2, this cross. Okay, so now on this section 1, just below the piston, the total pressure acting will be the sum of atmospheric pressure plus the pressure exerted by this frictionless circular piston. So let us find the pressure on water due to this 100 kg piston, which will be equal to mg by, you know, m, 100 kilogram, g is given as 10 meter per second square, so you have to use 10 meter per second square by area. What is the area of piston? It is 10 to the -2 meter square, so the units will be Pascal and the value will be 10 to the power 5. So this is the pressure that is exerted on water by this 100 kilogram piston. Okay, now apply Bernoulli's equation between 1 and 2. Okay, so P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2G plus Z2. Okay, P1 will be P-ATM plus this 10 raised to the power 5 Pascal pressure upon rho g plus V1 square by 2G plus Z1, and P2 I have taken this in atmosphere, so P2 will be P-ATM by rho g plus V2 square by 2G, okay, plus Z2. So I'm taking this as datum, so Z2 becomes 0 and Z1 becomes 0.5 meters. Great. And you can see from this equation that this P-ATM by rho g gets cancelled out by this P-ATM by rho g. Okay. Do not forget to write 10 raised to the power 5 by rho g in the next equation. Okay. This is actually P-ATM by rho g plus 10 raised to the power 5 by rho g. Okay. So this and this gets cancelled out. Do not forget to write 10 raised to the power 5 by rho g. Do not forget this rho g if you are cancelling it here only. Okay, do not commit this mistake. So 10 raised to the power 5 by rho g. This may seem trivial, but in examination these kind of mistakes do happen. Okay, so this is plus v1 square by 2g plus 0.5 is equal to v2 square by 2g. Okay, again this Bernoulli's equation has been clubbed with continuity equation in the question. You have to use continuity equation to get the relation between v1 and v2. So continuity equation is a1 v1 is equal to a2 v2. Okay, you know the areas. This is 10 to the power minus 2 meter square. v1 is equal to 10 to the power minus 3 meter square to v2. So 10 v1 is equal to v2. This will be the relation. Okay, now we have to find the velocity of piston. See the piston velocity, which is v1. So replace v2 in terms of v1. That will be 10 v1. Okay, so now when you solve it, I guess you can solve it, or only you have to find v1. So when you solve it, you get v1 as 1.456 meter per second. Okay, so you see basically the Bernoulli's equation is asked with this continuity equation. Okay, and this topic is very, very important for GATE. Every year there will be a question on Bernoulli's equation, continuity equation. Okay, so do prepare this topic very thoroughly. Next question. Air flows at rate of 1.5 meter cube per second. This is Q given, flow rate given, through a horizontal pipe with a gradually reducing cross section as in the figure. The two cross sections of the pipe have diameters 400 mm, that is 0.4 meter. I will write here only so that I will not commit any mistake. 400 meter mm. So the diameter will be 0.4 meter, and 200 mm, that is 0.2 meter. Take the air density as 1.2 kilogram per meter cube. The density of air is also given, and assume it inviscid incompressible flow. So that means we can apply Bernoulli's equation. The change in pressure P2 minus P1 in kilopascal. P2 minus P1. You can see from the figure that at point 2 pressure will be less than the pressure at point 1, because the velocity at point 2 will be greater than the velocity at point 1. So that means B and D get rejected automatically. So if your answer, if you after calculation, if you get your answer in a negative value, that means you have done the answer correctly. Obviously I'm not taking into the account that I'm taking into the account that you are not committing any calculation mistake. So if your answer is negative, that means you have calculated the correct answer. क्या बक रहा हूँ बे? So if you get your answer with a negative sign, that means your answer is correct. I'm taking into the consideration that you will not commit any calculation mistake. Okay. So now let's apply the Bernoulli's equation between this one section and two section. That will be P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2. As it is a horizontal pipe, so Z1 will be equal to Z2 and this gets cancelled out. Okay. Now we have to find P2 minus P1. So I will take this here so that I automatically get my answer. So V1 square by 2g minus V2 square by 2g is equal to P2 by rho g minus P1 by rho g. G गुजर गए. I mean they got cancelled out. So P2 minus P1 we have to find. Okay, so now for the relation between V1 and V2, let's apply the continuity equation. Again, same type of questions are getting repeated. Okay, so continuity equation is A1V1 is equal to A2V2. Right, now A1 will be pi by 4, diameter is given 0.4 meter, so pi by 4 0.4 square into V1. Okay, so in this we have to actually find the value of V1, not to only get the relation between V1 and V2. We have to actually find the value of V1 and V2 because we have to find P2 and P1, and we have been given with the airflow rate. So A1 V1 is equal to A2 V2, which is equal to Q. Okay, so pi by 4, A2 is pi by 4 0.2 square into V2 is equal to Q. Q is 1.5 meter cube per second. Always take care of the units. Okay, meter cube per second is given. So V1, when you compare this with 1.5 meter cube per second, you get V1 as 11.936 meter per second, and after comparing this with 1.5 meter cube per second, you get V2 as 47.746 meter per second. Okay, now what you have to do? All you have to do is put V1 and V2 in this equation and get P2 minus P1. So after putting these values and after putting rho is equal to 1.2 kilogram per meter cube, solve this, you will get P2 minus P1 is equal to minus 1282.355 Pascal. Okay, you have to find the answer. I mean, you have to tick the option kilopascal, so that will be minus 1.282 kilopascal. See, we got the answer. We got the answer with a negative sign. I've already told you earlier that we'll get the answer with a negative sign if we have to find P2 minus P1. Okay, thank you.